Suppose if a plane wave traveling through the curved parts, traveling through the curved surfaces. So what is the meaning of curved surface? Means maybe a curved mirror, curved lens, or a prism like this. This is a prism, an identical prism. Whenever a plane wave is traveling through the prism, the lowest portion of the wavefront, lowest portion like this, the lowest portion of the wavefront is traveling through the thickest portion of the prism. We know that in denser medium, speed of light is going to change. This causes to refraction. So, speed of light changes in denser medium. So what we can understand in this case, whenever the lowest portion of the incident wave traveling through the thickest portion of the medium or thickest portion of the denser medium, it emerges out in delay. Emerging by taking delay. Same thing happens if the same type of plane wavefront which is traveling through the lenses. Same wavefront, lenses. Maybe it is a convex or concave, whatever it may be. It's a convex lens, we know that. Again, the lowest portion of the wave traveling through the thickest portion of the lens. If the same light passes through the concave or convex, there is a beautiful delay because of that curve and the more curved in nature. So this phenomenon is called the delay propagation of the light. So when a plane wave traveling through the lens or mirrors, maybe it is a concave mirror or convex mirror, when it is traveling through the thickest portion, there is a little delay propagation of light. This delay propagation leads to refraction. So initially we had discussed about the refraction to internal reflection total, and here we discussed about reflection to refraction. So whenever a plane wave, the lowest portion of the plane wave or any polarized wave traveling through the thickest portion of the medium, then it can be a delay propagation, because it should take a more time to cover all the density part of the medium. So like this we can expect. So anyway, frequency is not going to change. Velocity will change and wavelength will change. Frequency won't changes. Like this it will create the form. The next concept is Doppler effect. In sound, we have observed this Doppler effect. There is a source. When source is moving away from the observer, there is a change in frequency, apparent frequency. When source is moving towards the observer, there is a apparent change in frequency. When both are moving or approaching towards each other, there is a special case of apparent frequency change. Such like that, this Doppler effect can be understood in concept of light also. Suppose if there is no source, or where there is no observer, let us suppose there is no observer, source is ready to emit the light waves. There is no observer, source is emitting the light waves, a transverse wave. These light waves should travel to the longer distance to reach any observer. Means in this case, longer wavelengths will be observed first. Means when source is moving towards the observer, then longer wavelengths will be visible first. When observer is moving toward the source, then the shorter wavelengths will be observed first. This phenomenon is called Doppler shift. See the astronauts. Astronauts are moving away from the earth. When these astronauts are moving away from the earth, for them it is a red shift will be observed. Why? In the middle, the spectrum region shifts to the red color. If these astronauts are coming towards the earth, for them it is blue shift. Suppose if the same concept is valid in the scattering of light. So what is scattering of light? Sunrise, sunset. At the time of sunrise and sunset, sun appears to be a thick red. What is the reason? It is exactly at one corner. Light ray should travel to the exact opposite corner, means long distance. When a light ray is traveling to the long distance, longest wavelength observes first. When it is coming like this, means this is the longest position. Like this it should be redshift. Same sun, change it to here as the days goes on. Sky appears to be blue. It's a blue shift. Means when source is moving away from the observer, it's a red shift. When source is coming towards the observer, blue shift. Such like that, astronauts moving away from the earth, they will experience the red shift. When astronauts are moving towards the earth, they will experience the blue shift. Means this shift in colors is respective to the frequency change. This respective frequency change, we can say it as delta nu by nu is equal to minus v radial by c. What is this minus v radial? This is a velocity vector which joins the source and receiver, or source and observer, where c is speed of light. But this frequency change will be more because the speed of light is more than the speed of sound. This is very, very important one. So we can understand this apparent change in frequency delta nu by nu. Apparent change in frequency is equal to minus v radial by c. So what is this minus v radial? So v radial is defined as like this. It is a component of source of velocity. Source of velocity along the line joining the observer to the source relative to the observer. So v radial is a component of source of velocity along the line joining the observer to the source relative to the observer, means when they are approaching towards each other, relativity. This minus v radial by c, this radial velocity component is positive. V radial is positive when source is moving away from the observer. Away from observer. So as well as if source is moving towards the observer, negative. Towards the observer, it is negative. So what we can understand in this situation is what is the red shift and blue shift. If the light waves are received from a source which is moving towards the observer, that is blue shift. When a light waves are received by a source when it is moving away from the observer, that is red shift. So this is blue shift. Redshift is nothing but due to the change in frequency comparable to the change in frequency in the sound case of Doppler.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.